All right, so the next thing here that we might want to construct is an altitude. So an altitude is a height of a triangle. So especially if you ever think about your middle school and finding out like the height of a triangle, what happened is the height is actually sometimes, especially like in this obtuse triangle, it's outside of the triangle. So some people will assume it's this side here, but that's just the side of a triangle. We want the height, and the height meets at 90 degrees. So how do we construct that? So the way we construct that, again, with a compass and a straight edge, meaning a ruler. And then here's our school compass, again, one that doesn't have the pointy ends. So the idea is that I'm going to take, at least the first thing, is I'm going to take my ruler and extend the side that I'm going to create the height for. So especially when it comes to an obtuse triangle, if you don't extend the side, you're probably not going to get the points that you need. So we're going to extend the side that I'm going to try to find the height for. So as I kind of pictured earlier, the height is going to be the distance between this point and this line at 90 degrees. So the first thing that we do in our altitude construction is extend the side you are finding the height for. Again, especially for obtuse triangles, like this example is. All right, so again, extend the side. So we've extended the side, and the reason that we extended the side is because now I'm going to make a circle. Again, you put the center of your compass here on the vertex. So I'm going to create a circle on the vertex that's across from the line I just extended. So neither of these two vertexes, but this one, vertices. So I'm going to put it on the center here, and then I'm going to choose a dot on my compass that is going to actually intersect. So if I made a circle that kind of used this dot here, I wouldn't meet this line, and I want to meet that line. So I'm going to create a circle that has a radius centered at my opposite vertex that will intersect this line opposite twice. So I'll go ahead and use this one. All right, so again, when I do this, I don't tend to make the whole circle because that just ends up looking like a lot of circles. So all I did was center on this one and create a circle that will meet this purple line that I extended twice. So that's what's happening in step 2. So step 2 is create a circle that crosses the line you extended. Number 1, twice, again centered on the opposite vertex. So we've got our circle that's centered on the opposite vertex, and now, if you haven't noticed, what we have is a segment, and that segment is what we're going to bisect. So if you imagine all of the other videos, pretty much everything comes from creating a segment and then perpendicularly bisecting that segment. So here we are with the segment that I wanted to create. So it's between this point here where it met and this point here, and I'm going to create the perpendicular bisector. So I'm going to ignore all the rest of this stuff at this moment, and I'm going to create a perpendicular bisector based on this segment. So we are now going to create so we've created a segment that connects the circle and the extended segment, or the extended side. And then we want to perpendicularly bisect that. And so going back to how to perpendicularly bisect, what we're going to do is create 2 circles. So the first thing from that is going to create 2 circles on the endpoints of that segment. And remember, these circles should intersect. If they don't intersect with each other, then you haven't created that cat eye that you need. So I'm going to get my compass and center it on the one endpoint of the segment. And remember, I'm making something that is bigger than half, so I'm going to create this one. And then create this one. And so again, I have not created the whole circle, but they are there if you wanted to continue out. And so these two meet here, and I want to connect those points because that will actually make my height. So in part B, I create 2 circles and with endpoints of the segments, and now we want to connect the circle intersections, because that creates the perpendicular bisector. Interestingly enough, of that perpendicular bisector, if you want to then go all the way to actually constructing the altitude extends the perpendicular bisector through that opposite vertex. So over here, if I created this appropriately, which it looks like it's a little bit off, but the idea is that I would connect these 2 dots, and once I connect those 2 dots, it would in fact go through the vertex as well. So here I am connecting the 2 dots, and so that is my perpendicular bisector. But if I went ahead and continued this line, it turns out I would make the altitude that would then go through the vertex. So this is my altitude, but before that it was the perpendicular bisector. All right, so officially the altitude is the height of the triangle, and that would be this part right here. So if you ever want the height of a triangle, again, this is the construction for that. Sometimes, and if you flip this around, the height is inside the triangle, okay? But when it comes to obtuse triangles, sometimes the height is outside. So that is creating the altitude of a triangle. And again, here are the steps. The altitude extends that perpendicular bisector that we made.